everyone. You'll recall, I think, that we were talking about z-scores, also known as z-scores. And we defined what a z-score is, and we talked about it being a standardized score. And by standardized, it means that when it's been converted using a mathematical formula, the original score, called the raw score, now becomes a z-score, and it belongs on the z-score distribution. So you can take raw scores, such as these, green apple scores and the orange scores. You can take scores from any distribution, apply that same mathematical formula, convert them all to z-scores, and then once they're all z-scores, they fall in the same distribution, which allows you to compare them. And that way you can answer questions about relative worth, or I use the analogy, which one shines the brightest if you're comparing your performance in different classes, etc. Anyways, if you don't remember the first part of Chapter 5, or if you didn't watch that lecture, go back and watch it before you watch this one, because you'll be a little bit lost if you, like I said, if you don't remember the first part or if you haven't watched it. Okay, so what else are z-scores good for? We know that they allow us to compare apples and oranges, and I introduced this at the end of the first lecture. This is what we're going to be focusing on for the first little while of this lecture, and then we're going to turn our attention to t-distributions and how they are the same and different from z-distributions, and when you would use t instead of z, all that fun stuff. All right, so a second use for z is once you know the z-score, you can calculate the probability of getting above that z-score. So that raw score is going to get converted to z, and then you can figure out the probability of getting above it. You can figure out the probability of getting below that raw score. Again, you have to convert it to z to find out, but once you convert it to z, you can find out the probability of getting below it. And then, of course, you can figure out the probability of getting between two raw scores once you convert both to z. So I'm going to show you how that's done and why we would do it. And the first reason why we do this is something that you're all very familiar with, but you might not just realize it. And that is that if we convert a raw score to z and we look at the probability of getting below it, actually at and below it, those are called percentiles. Right? Percentiles. So that's probably very familiar to you. When you were growing up, if you went and saw the doctor, there's a good chance, just for like a regular, well check, there's a good chance that the doctor would have measured your height and your weight and would have, said to your parents and to you, oh, you're in the 50th percentile or the 80th or the 20th, but they would have assigned you some sort of percentile. And you probably understand that that is a measure of how well you're doing or where you are relative to others on that measure. All right. So if we figured out, I'll give, the example of my sons, actually. I remember going to the pediatrician, every year we'd take the boys in, and they were in opposites in terms of their percentiles in the height category. So Burgess, my firstborn, until he was about maybe 15 or 16, he was in the 1 percentile for height, which means he barely showed up on the chart. Now, if you think about it, that's, the percentile is the probability of being at or below a certain score. So we can rephrase this and say that if you're in the 1 percentile, that means 1% of people were that height or shorter, at or below. So that means Burgess, for, the first 15 years of his life or so, he was really, really, really short, okay, because he was barely on the charts. Now, on the other hand, my second born, my youngest, because I only have two, Troy was at the other end. He was at the 85, sometimes 90th percentile for height, which means, let's say if we use the 90th percentile, it means that 90% of the children his age were his height or shorter. All right. Now, I know that there's that temptation to say, oh, so a percentile means only 10% are at or above you. And although there's good logic to that, to say, yes, that's what it means, we don't say it that way. A percentile is always expressed as the percentage of scores at or below a given score, never at and above. All right, so do not fall into that mistake, because I'm going to put that either as a quiz question or a test question. I'm going to try and catch you, right? So the saying that 90% of the kids Troy's age were his height or shorter is the same thing as saying the probability of a child just being picked at random being that height or shorter is 90%. Okay, so if you were to reach into the population with this big hand and just grab somebody out, some kid his age out at random, there's a 90% chance that he would be Troy's height or shorter. Okay? All right. So the percentile then is defined as the percentage of people, or dogs or cats or whatever it is, but the percentage of people scoring at or below a given score. Now, in order to calculate this percentile, you first need to know how to find areas under the curve. Once you know how to do that, you can calculate the percentile for anything.